Inside your phone, a technological metaphor, a single microchip packed up to 90 billion transistors. How do we build something this impossibly dense? We start by refining a raw quartzite into a pure crystalline silicon ingot. Wafer is thin and about 300 nanometers in wide. Next, high-speed spin coated floods the wafer with a golden and light-sensitive chemical. Then the layer of a light-sensitive photoresist is spread across the top of a wafer. Wafer went to soft bake. Lithography machine that blasts an extreme ultraviolet light through a glass stencil, shrinking the architectural blueprint 4 times over to bake the circuit design into the surface. Chemicals then wash away the exposed sections and leaving a flawless and protective mask. High energy then plasma beams then strikes like lightning, etching deep canyons into the oxidized layer. And attracts like an atomic canyon bombards with an exposed silicon with elements, forcing to open positive and negative zones to create transistor gates. To connect them, vaporized copper then floods the wafer and filling the trenches. Heavy abrasive polished pad grinds the surface to the mirror finish and leaving behind the flesh and isolated wire pathways. Next cycle is to begin, where the insulated silicon dioxide rods are added. Then cleaning takes place. The intense cycle is repeats over and over and stacking an impossible complex 3D labyrinth of 17 distinct layers of copper wiring. After 3 months and nearly 1000 steps, and the completed wafer faces a rigorous test. Defective sections are mapped out and sorting the survivors into different performance tiers. Perfect chips are laserly cut and flipped onto the logic boards and sealed under the heat pads and ready to use in the modern world.